In the vast, silent expanse of the cosmos, a celestial wonder unfolds, a symphony of celestial bodies, each playing its unique role in a cosmic dance that has captivated the human imagination for millennia. Welcome to our solar system, an enigmatic realm of awe-inspiring mysteries and celestial secrets that have beguiled scientists, stargazers, and explorers since time immemorial. At its heart, a blazing sphere of searing plasma reigns supreme, the Sun, a colossal, radiant force that bathes the entire system in life, giving warmth and light. Its magnetic presence, both nurturing and ruthless, governs the fates of all who dare to enter its gravitational embrace. A solar prominence, often referred to simply as a prominence, is a stunning and dynamic feature of the Sun. These are massive arcs or loops of hot, glowing gas that extend outward from the Sun's surface into its outer atmosphere, the solar corona. Prominences are some of the most spectacular phenomena visible during a solar eclipse, but they're also observable with specialized solar telescopes at other times. Prominences are formed due to the complex and often poorly understood interactions of magnetic fields on the Sun's surface. Magnetic fields can become twisted and tangled, leading to the eruption of these arching structures. Prominences are primarily composed of hot, ionized gas, mainly hydrogen and helium, although other elements are also present. This plasma can reach temperatures of tens of thousands of degrees Celsius. Solar prominences can take on a variety of shapes, including loops, arches, and even towering plumes. They appear as bright, gaseous structures against the dark background of space. The color and intensity of their light depend on the temperature and density of the gas. Prominences can be relatively stable, lasting for several weeks, or they can be highly dynamic, changing rapidly over the course of hours or days. These structures are enormous, often extending many times the diameter of the Earth. Some prominences can reach heights of hundreds of thousands of kilometers above the Sun's surface. Solar prominences are closely related to solar flares and coronal mass ejections, CMEs. When they become unstable and erupt, they can release huge amounts of energy and matter into space. If directed toward Earth, CMEs can impact our planet's magnetic field and cause geomagnetic storms. Observing solar prominences is a challenging task due to the intense brightness of the Sun. Specialized solar telescopes equipped with filters that block most of the Sun's light are used to study these structures safely. They are often seen during total solar eclipses when the moon blocks the Sun's bright disk, revealing the fainter solar corona and prominences. The study of solar prominences is important for understanding the Sun's magnetic field, its activity cycle, and its impact on space weather. It can also provide insights into plasma physics and magnetohydrodynamics, which have applications beyond the study of the Sun. Mars, often referred to as the Red Planet, has long captivated human imagination and scientific curiosity. It is a celestial enigma that holds immense significance, both in terms of our understanding of the universe and our aspirations for the future. Mars is believed to have had a more Earth-like past, with clues such as dry riverbeds, ancient lake beds, and evidence of liquid water, suggesting that Mars may have once harbored life, or, at the very least, conditions conducive to life. The suspense lies in unraveling the mysteries of what happened to this potentially habitable world and whether it ever hosted life. The search for life beyond Earth is one of the most profound quests in science. Mars presents a tantalizing opportunity. Ongoing missions and future expeditions aim to search for signs of past or present life, pushing the boundaries of astrobiology. The suspense of a possible discovery of extraterrestrial life on Mars keeps scientists and the public on the edge of their seats. The prospect of sending humans to Mars is one of the most exciting and suspenseful ventures of our time. The dream of establishing a permanent human presence on another planet, with all the technical and survival challenges it entails, fuels the imagination and ambition of space agencies and private companies. The idea of terraforming Mars, transforming it into a more Earth-like environment, is a thrilling concept that could potentially expand human reach in the cosmos. While the practicality of this idea is a subject of debate, it represents the kind of bold and suspenseful thinking that could shape the future of humanity. Mars is a unique laboratory for studying planetary geology and climate. The planet's surface is marked by stunning features, including the largest volcano in the solar system, Olympus Mons, and the longest canyon, Valles Marineris. Its thin atmosphere and shifting climate patterns are subjects of intense scientific investigation, providing insights into Earth's own geological history and climate evolution. Mars holds the promise of valuable resources that could be harnessed for future space missions. Water ice in the polar regions could provide drinking water and serve as a source of hydrogen and oxygen for rocket fuel. Additionally, the planet's regolith, surface material, could be used for construction and shielding against radiation. The exploration of Mars has the potential to bring nations together in the spirit of international cooperation. This is particularly suspenseful as it challenges us to work collectively to overcome the challenges of space travel, fostering diplomacy, unity, and peace on Earth. The significance of Mars also lies in its role as a stepping stone for humanity's exploration of the unknown. It forces us to develop advanced technologies, problem-solving skills, and resilience that will be essential as we venture further into the cosmos, possibly beyond our solar system. The quest to explore Mars raises ethical and philosophical questions about the rights of any potential Martian life forms, our responsibilities as explorers, and the long-term consequences of our actions on the planet. The suspense here lies in the moral dilemmas that future explorers may face. Mars, with its striking reddish hue and the allure of the unknown, continues to inspire the human spirit. Its significance is not just in the data and knowledge it offers, but in the wonder it instills, motivating future generations to reach for the stars. Mars, with its history, mysteries, and promise, embodies the human spirit of exploration and our innate curiosity about the cosmos. The suspense of what lies ahead on this neighboring world keeps us looking to the heavens with anticipation and awe. Earth, our home planet, is a unique and complex celestial body situated in the solar system. It is the third planet from the Sun and the only one known to support life. Earth is the fifth largest planet in the solar system. It has a diameter of approximately 12,742 kilometers. Earth is an oblate spheroid, meaning it is mostly spherical but slightly flattened at the poles and bulging at the equator due to its rotation. Earth's atmosphere is primarily composed of nitrogen, about 78%, and oxygen, about 21%, with trace amounts of other gases. The atmosphere plays a crucial role in maintaining temperatures suitable for life through the greenhouse effect, which traps heat from the sun. Earth's climate is remarkably diverse, with regions ranging from polar ice caps to scorching deserts and lush rainforests. Climate patterns are influenced by factors such as latitude, elevation, ocean currents, and atmospheric circulation. Earth's surface is characterized by a variety of landforms, including mountains, valleys, plains, plateaus, and coastlines. Plate tectonics, the movement of Earth's lithospheric plates, shapes the planet's surface and is responsible for phenomena like earthquakes and volcanic activity. Earth's hydrosphere comprises water in the form of oceans, rivers, lakes, and glaciers. Oceans cover about 71% of Earth's surface and contain an abundance of life, including various marine species. Earth is the only known planet to support life. The biosphere encompasses all living organisms, from microscopic bacteria to complex multicellular organisms like humans. The diversity of life on Earth is astonishing, with ecosystems ranging from deep ocean trenches to high mountain ranges. Human activities have had a profound impact on the planet, including deforestation, pollution, habitat destruction, and climate change. Conservation efforts are crucial to preserve Earth's biodiversity and ecosystems. Earth's systems are interconnected through various cycles, such as the water cycle, carbon cycle, and nitrogen cycle. These cycles play essential roles in regulating the planet's climate and supporting life. Earth has been a starting point for human space exploration, with missions to the Moon, Mars, and beyond. Studying other celestial bodies helps us understand Earth better and expands our knowledge of the universe. Earth faces various environmental challenges, including climate change, loss of biodiversity, and resource depletion. Addressing these challenges is vital for the well-being of current and future generations. Earth's position in the habitable zone, its abundant liquid water, and the complex interplay of geological and environmental factors make it a unique oasis in the cosmos, teeming with life and wonder. Mercury, the closest planet to the Sun in our solar system, is a world of extreme contrasts and enduring mysteries. Its story is one of suspense and discovery, filled with tantalizing questions about its formation, composition, and history. Let's delve into the detailed and suspenseful realm of Mercury. Mercury exists in a harsh and unforgiving environment. With no substantial atmosphere to speak of, it is bombarded by the Sun's unrelenting radiation, causing surface temperatures to swing dramatically. Daytime temperatures can soar to 430 degrees Celsius, while nighttime temperatures plummet to -180 degrees Celsius. Being the closest planet to the Sun, Mercury is exposed to intense solar radiation. This radiation exerts a powerful influence on its surface, eroding and scorching the planet. Mercury's surface is a testament to its tumultuous past. It is densely pockmarked with craters, evidence of eons of cosmic impacts. Some craters are surrounded by bright rays, suggesting relatively recent impacts that exposed lighter-colored material beneath the surface. One of Mercury's most striking features is the Caloris Basin, a colossal impact basin roughly 1,550 kilometers in diameter. This immense crater is a scar from a cosmic collision that occurred billions of years ago. It's surrounded by a series of concentric ridges known as ghost craters and fractured terrain. Mercury also boasts a perplexing system of tectonic features, including enormous cliffs or scarps. These cliffs, some of which extend for hundreds of kilometers, are believed to have formed as the planet's interior cooled and contracted, causing the crust to fracture and buckle. While Mercury lacks a substantial atmosphere, it does have an exosphere composed of trace amounts of hydrogen, helium, oxygen, and other elements. This extremely thin exosphere is constantly replenished by solar wind and sputtering of the surface. Despite its extreme heat, Mercury harbors water ice in permanently shadowed craters near its poles. These regions are sheltered from the sun's scorching rays and provide scientists with insights into the planet's volatile history. Mercury has a unique rotation pattern. It rotates on its axis at about a 3:2 resonance with its orbit around the Sun. This results in one of the slowest axial rotations in the solar system, causing day and night temperatures to vary dramatically. The European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, launched the Bepi-Colombo mission in 2018, which is set to arrive at Mercury in the coming years. It will provide invaluable insights into Mercury's composition, magnetic field, and geological history. Mercury's formation is still a subject of intrigue and debate. It's thought to have formed from the solar nebula, but its small size and proximity to the Sun present challenges for explaining its origin. Mercury is a world of extremes and enigmas, challenging our understanding of planetary evolution and solar system dynamics. Its history, formation, and geological features continue to captivate scientists and space enthusiasts alike, making it a realm of perpetual suspense and discovery in our cosmic neighborhood. Jupiter, the largest planet in our solar system, is a colossal and captivating world that has enthralled astronomers and space enthusiasts for centuries. Its intriguing characteristics and enduring mysteries make it a subject of fascination and exploration. Here is a detailed look at the planet Jupiter. With a diameter of approximately 139,822 kilometers. This is more than 11 times the diameter of Earth. Jupiter is classified as a gas giant, primarily composed of hydrogen and helium, similar to the composition of the Sun. It lacks a solid surface, and its gaseous atmosphere transitions gradually into a dense metallic hydrogen core. Jupiter boasts one of the strongest magnetic fields in the solar system, around 20,000 times stronger than Earth's. This powerful field generates intense radiation belts and a complex magnetosphere. The Great Red Spot is one of Jupiter's most famous features. It's a massive storm, larger than Earth, that has been raging for at least 350 years. The exact cause of its reddish color and the persistence of the storm remain topics of scientific investigation. Jupiter possesses a faint and thin ring system. While not as prominent as Saturn's rings, Jupiter's rings consist of small, dark particles and are divided into several main ring groups. Jupiter has a vast retinue of moons, with over 80 confirmed and more awaiting official classification. 4 of its largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, are among the most massive objects in the solar system. Io, one of the Galilean moons, is the most volcanically active world in the solar system. It boasts hundreds of active volcanoes, spewing sulfur and other materials into space. Europa, another Galilean moon, is believed to harbor a subsurface ocean beneath its icy crust. This has made it a target of interest in the search for potential extraterrestrial life. Jupiter's powerful magnetic field interacts with Io, inducing electrical currents in the moon's interior. This interaction results in tremendous volcanic activity on Io. Jupiter has been a focal point of scientific exploration. NASA's Juno spacecraft, which arrived at Jupiter in 2016, is studying the planet's composition, gravity field, magnetic field, and polar magnetosphere, providing unprecedented insights into its structure and evolution. Jupiter is thought to have played a crucial role in the early solar system's formation by acting as a cosmic vacuum cleaner, capturing or diverting potential planetesimals and debris that could have posed a threat to Earth and other inner planets. Despite our growing knowledge of Jupiter, many mysteries remain, including the nature of its core, the depths of its atmosphere, and the origins of its magnetic field and auroras. Saturn is the second largest planet in our solar system, known for its distinct ring system. It has a diameter of approximately 116,464 kilometers and is predominantly composed of hydrogen and helium, like Jupiter. Saturn's rings are its most iconic feature. These rings consist of countless individual particles of ice and rock that range in size from tiny grains to several meters in diameter. The ring system is divided into several main ring groups, with the largest and most prominent being the A, B, and C rings. Saturn has more than 80 confirmed moons, with its largest moon, Titan, being the second largest moon in the solar system. Titan is of particular interest due to its thick atmosphere and the presence of lakes and rivers of liquid hydrocarbons on its surface. Its magnetic field is approximately 578 times stronger than Earth's. Its powerful magnetosphere influences its environment and causes spectacular auroras at its poles. Saturn's North Pole features a mysterious and persistent hexagonal-shaped storm system, a striking atmospheric feature that has puzzled scientists for years. Neptune is the eighth and farthest known planet from the Sun in our solar system, located over 4.5 billion kilometers from Earth. Neptune's vivid blue color is due to the presence of methane in its atmosphere. Methane absorbs red light and reflects blue light, giving the planet its distinctive hue. Neptune's atmosphere is characterized by extreme winds, including the fastest recorded in the solar system, with gusts reaching over 2,100 kilometers per hour, 1,300 miles per hour. A prominent feature is the Great Dark Spot, a massive storm similar to Jupiter's Great Red Spot, which comes and goes in Neptune's atmosphere. Neptune has a faint ring system, as well as a diverse group of 14 known moons. The largest moon, Triton, is unique because it orbits Neptune in a retrograde direction, opposite to the planet's rotation. Cryovolcanism on Triton. Triton is believed to be geologically active, with cryovolcanism, volcanic activity involving icy substances, and plumes of nitrogen gas and dust erupting from its surface. Uranus is the seventh planet from the Sun and is unique in the solar system for its extreme axial tilt. While most planets have their axes nearly perpendicular to their orbits, Uranus is tilted almost 98 degrees, causing it to rotate on its side. It has a bluish-green appearance due to the presence of methane in its atmosphere, which absorbs red and reflects blue and green light. It is composed primarily of hydrogen and helium, along with traces of methane, water, and ammonia. Uranus has a faint and dark ring system, which was discovered in 1977 when the planet passed in front of a star, causing the star's light to dim. This planet has 27 known moons, including Titania and Oberon, the largest and brightest, and Miranda, a moon with a highly varied and fractured surface. This is one of the coldest planets in the solar system, with temperatures dropping to around -224 degrees. NASA's Deep Space Observing Telescope is looking at the universe like never before. The James Webb Space Telescope, Webb or JWST, is a pathfinder of scientific discovery, generating incredible insights about galaxies, planets, stars, and all sorts of interesting cosmic objects. The telescope is near the beginning of its cosmic journey, as it is rated for 20 years of operations and just launched in December 2021. Billed as a successor to the venerable Hubble Space Telescope, Webb is also breaking ground in science excitement. When Webb launched on Christmas Day of 2021, it was the culmination of decades of work by NASA scientists and engineers. The launch went off without a hitch, as did the numerous steps of the telescope's deployment in the following months. In mid-July, Webb released its stunning first images. The infrared telescope will help us see almost every part of our universe in greater detail, including the most distant galaxies, allowing us a glimpse into the past. Within days of the telescope coming online in late June 2022, researchers began discovering thousands of new galaxies more distant and ancient than any previously documented. Some perhaps more than 150 million years older than the oldest identified by Hubble, editors of the journal Science wrote in a statement. What's more, the telescope is capable of collecting enough light from astronomical objects, ranging from birthing stars to exoplanets, to reveal what they are made of and how they are moving through space, the editors of Science wrote. This data has already begun to reveal the atmospheric composition of planets hundreds of light years from Earth in great detail, offering hints as to their ability to potentially support life as we know it. The Pillars of Creation in the Eagle Nebula has long been one of the Hubble Space Telescope's most iconic images. But though the telescope, which detects mostly visible light, captured the structure's impressive clouds, the creation happening within them was hidden. Now, Webb's infrared imaging has managed to capture it in the form of numerous protostars. Appearing as tiny red dots against the smoky backdrop of the pillars, these collections of dust and gas, each many times larger than our solar system, are stars being born. These young stars that we see in the image are not yet burning hydrogen. Derek Ward Thompson, head of the School of Natural Sciences at the University of Central Lancashire in the UK, told Space.com in October. But gradually, as more and more material falls in, the middle becomes denser and denser, and then suddenly it becomes so dense that the hydrogen burning switches on, and then suddenly their temperature jumps up to about 2 million degrees Celsius. Though the phantom galaxy is difficult to find in the night sky, its brilliance is far from invisible, especially when captured in infrared with Webb. Hubble's optical image of the galaxy, also called M74, shows the galaxy's perfect spiral structure and its distribution of stars, arms extending outward from a radiant center. But a new Webb image reveals fiber-like structures of heat-emitting dust and gas emanating from a bright center rendered in vivid electric blue. The new image will shed infrared light on star-forming regions scattered amongst the galaxy's spiral arms. A mesmerizing composite image combining the Hubble Space Telescope and Webb images features aspects of both optical and infrared observations of the galaxy. In July, Webb captured an image of a distant star called a Wolf-Rayet star, which featured Webb's signature diffraction pattern, an imaging artifact. But around the star, called WR140, is a pattern that looks equally unreal, a ripple-like pattern of concentric rings that have a peculiar, slightly boxy shape. Unlike the diffraction pattern, the unlikely shaped rings are real features. The six-pointed blue structure is an artifact due to optical diffraction from the bright star WR 140. Wolf-Rayet stars are massive stars nearly the end of their lives, already having released much of their hydrogen into space. The strangely shaped rings are caused by the interaction between WR 140 and its smaller companion star. The stars are surrounded by a cloud of dust that is sculpted into that shape by its companion star. Webb was made to observe the most distant galaxies in the universe, and in mid-December, scientists confirmed that they had done just that. The telescope has officially observed the four most distant galaxies known, which also means they are the oldest. Webb observed the galaxies as they appeared about 13.4 billion years ago, when the universe was only 350 million years old, about 2% of its current age. Scientists suspected that the four galaxies were incredibly ancient, like hundreds of others identified by Webb. While the universe is a vast and fascinating place, there are some planets and celestial bodies that, by human standards, might be considered horrifying due to their extreme conditions or inhospitable environments. Here are a few examples. Corot 7b, a distant enigma residing 489 light-years away in the constellation Monoceros, challenges our understanding of the cosmos. This rocky exoplanet, sometimes dubbed a super-Earth, beckons us into a world of extremes, where science and imagination collide. Corot 7b's proximity to its parent star, Corot E7, pushes the boundaries of what we thought possible. Orbiting at a breakneck pace, it completes an entire orbit in just 20.4 hours, a fraction of the time it takes Earth to go around the Sun. Yet, this cosmic speedster's mysteries don't stop there. The exoplanet's temperatures swing to mind-boggling extremes. On its day side, the heat is downright otherworldly, with thermometers soaring to a blistering 2,200 degrees Celsius, 4,000 degrees Fahrenheit, hot enough to liquefy rock. But then, darkness descends, and on the night side, a chilling void rules, where temperatures plummet into the abyss. Corot 7b's fate is sealed by its proximity to its parent star. It is tidally locked, a celestial prisoner where one side basks eternally in scorching sunlight, while the other languishes in perpetual darkness. This division creates a stark and unforgiving duality, where no life as we know it could ever exist. Peering into Corot 7b's inky depths, we yearn to unlock the secrets of its atmosphere. Hidden behind the cloak of extreme temperatures, it's a riddle that scientists can only speculate about. Could it be a turbulent mix of vaporized rock, or perhaps shrouded in enigmatic silicate clouds on its day side? Corot 7b made a mark on the annals of astrophysics when its discovery was confirmed. It was one of the first rocky exoplanets, and its detection by the transit method, as it passed in front of its parent star when seen from Earth, was a breakthrough that expanded our horizons of planetary exploration. J 147b, a distant enigma lurking in the far reaches of space, invites us to journey into a realm of mysteries and marvels. This exoplanet, known for its mind-bending characteristics, unveils a narrative filled with suspense and the unknown. Nestled in the constellation Centaurus, J1407b orbits a sun-like star, and its secrets challenge the boundaries of what we thought possible. Its colossal ring system, like none other in our solar system, unfurls a cosmic enigma. The planet's rings are a mesmerizing spectacle, extending outward for vast distances, dwarfing the most extravagant ring systems known to us. They enshroud J 1407b in an aura of otherworldly grandeur. Within this ringed realm, mysteries abound. How do these rings form and persist on such a grand scale? What unseen forces sculpt their intricate patterns? And what secrets do they hold about the planet's history and evolution? J. 147b's mass and characteristics remain shrouded in cosmic shadows, and the quest to unveil its true nature has become a compelling cosmic quest. Scientists and astronomers yearn to decipher the enigma of this distant world, to unravel its secrets and fathom the depths of its mysteries. This exoplanet, with its colossal rings and a story etched in the stars, beckons us to embark on an odyssey of discovery. It is a testament to the boundless wonders of the universe, where the unknown meets the unfathomable and where suspense and intrigue shape the narrative of exploration. In the cosmic theater, far beyond the reach of human touch, lies PSOJ 318. 522, a celestial riddle that beckons us to venture into the unknown. It's a realm where the line between science and science fiction blurs, a place of mind-bending enigmas and undying suspense. Nestled in the distant constellation Centaurus, this exoplanet, an outlier in the celestial tapestry, dances in eternal orbit around a sun-like star. But what sets it apart, what draws us into its cosmic enigma, is a feature so astounding it defies the limits of our imagination, a ring system of unimaginable proportions. The rings of PSOJ 318 are an intricate spectacle, extending to distances that defy all comparisons. They eclipse the grandeur of our most extravagant celestial adornments, cloaking the planet in an aura of otherworldly splendor. Yet, within this beauty lies a labyrinth of enigmas. How did these colossal rings come into being, and what cosmic forces sculpted their mesmerizing patterns into the inky abyss of space? The mysteries they guard about the planet's origins and evolution are hidden behind layers of cosmic secrecy, daring us to seek answers. The mass and characteristics of PSOJ 318 remain shrouded in shadows, a cosmic enigma that has driven scientists and astronomers to relentless quests of discovery. Their insatiable curiosity yearns to unmask this celestial enigma, to unravel its deepest mysteries, and to decipher its cosmic code. In the deep recesses of the cosmos, where worlds beyond our imagination lurk, there exists a place of enigmatic allure, a planet known as WASP-12b. This cosmic enigma beckons us into its gravitational embrace, shrouded in mysteries that defy our understanding. In the constellation Auriga, WASP-12b orbits its blazing host star, a star that outshines our sun. But this planet, a world beyond reckoning, doesn't bow to the norms of the celestial dance. It challenges the laws of nature in its orbit, closing in on its star at a perilous proximity that defies all reason. But what truly sets WASP-12b apart is its cloak of darkness. Unlike the vision we hold of sunlit worlds, this exoplanet absorbs almost every ray of light that touches its surface, creating an eerie, pitch-black orb that seems to defy the very essence of celestial radiance. Within the inky shroud of WASP-12b, a series of questions linger like cosmic riddles. What sinister forces allow it to exist in such proximity to its star without being consumed? How did it become this haunting embodiment of darkness, refusing to reflect the starlight that falls upon it? The enigma deepens as we consider its destiny, an inevitable spiral into its star, a fate that has scientists astir. For how much longer can WASP-12b defy its impending doom? Its mysteries are a siren's call to the curious and the intrepid, urging them to uncover the truths that lie beneath its enigmatic facade. And the hushed corridors of astronomical research, where scientists delve into the cosmic unknown, one celestial enigma looms, an enigmatic body known only as formalhaut b. It beckons us from the depths of the cosmos, a world that defies easy categorization, shrouded in suspense and curiosity. Nestled in the constellation Piscis Austrinus, formalhaut b dances in orbit around its parent star, formalhaut, a young and brilliant sun. But the intrigue of this enigmatic celestial body lies not just in its host star, but in its elusiveness, a world that seems to challenge the boundaries of what we thought possible. Formalhaut b's spectral signature hints at a unique and mysterious nature. It is often referred to as a rogue planet or a disputed exoplanet, an object whose origins and nature elude simple classification. It remains a point of intense scientific scrutiny, yet its true essence remains concealed. What sets this enigma apart is its apparent resistance to definition. Is it a planet, a wandering celestial body with an unknown history? Or does it hold secrets beyond our comprehension, offering a glimpse into the cryptic corners of the cosmos? As we delve into the depths of formalhaut b's mysteries, we confront a tapestry of questions. How did it come to be in this distant realm, defying easy classification? What mysteries and insights might it hold about the cosmic processes that have shaped it? In the far reaches of the cosmos, nestled within the folds of the Serpens constellation, lies a world of intrigue and fascination, Captain B. This exoplanet, though unobservable to the naked eye, emerges as a beacon of wonder in the tapestry of the universe. Captain B's existence hinges upon the light of a modest red dwarf star, Captain's star, one of the closest stars to our Sun. This small and unassuming celestial body hosts a planetary companion, a super-Earth. Yet, it is a planet that holds a litany of mysteries in its grip. One of the most captivating aspects of Captain B is its location. It dwells in the habitable zone of its star, where conditions may allow for the presence of liquid water, the elixir of life. Such a prospect spurs the imagination, kindling the desire to unearth the secrets of its potential biosphere. This exoplanet's origins remain obscured in the annals of time. The mysteries of its formation, its composition, and its history are shrouded in cosmic secrecy. It stands as a testament to the countless enigmas yet to be unraveled in our exploration of the universe. Now let us embark on a detailed journey into the heart of this cosmic mystery. Central to our fascination with black holes is their colossal gravitational force, an omnipotent presence that demands our attention. Picture standing at the precipice of a boundless abyss, gazing into the infinite void, where gravity's relentless pull tugs at every fiber of your being. This gravitational prowess is the hallmark of a black hole, a force so relentless that not even the fastest entity in the universe, light itself, can evade its gravitational clutches. It is an awe-inspiring attraction that draws everything in, a display of cosmic might that sparks both wonder and trepidation. To delve deeper into the intricacies of black holes, one must grapple with the concept of the event horizon. This invisible line, akin to a phantom boundary, delineates the point of no return. Once crossed, there is no turning back. It is akin to being lured down a labyrinthine corridor, each step taking you further into an inescapable darkness, a harrowing narrative of doom that keeps one at the edge of their seat. Imagine the disquieting sensation of being drawn into the maw of an insatiable beast, the event horizon marking the threshold of the unknown, a chilling countdown to an unfathomable fate. One of the most captivating facets of black holes is their ability to warp time itself. As you approach the event horizon, time becomes an elusive specter, its rhythm disrupted and contorted. What feels like seconds on your clock may translate into minutes, hours, or even centuries for an observer safely distanced from the black hole's clutches. This temporal conundrum adds a layer of mystery as we consider the eerie implications of this phenomenon. It's as if time, the constant companion of our existence, becomes a silent witness to our descent into the unknown, counting down our moments as we teeter on the precipice of the abyss. Within the event horizon of a black hole, the very laws of physics unravel, and the space-time continuum morphs into a turbulent chaos. Mystery deepens as we grapple with questions that defy conventional understanding. What befalls the matter and energy engulfed by a black hole? Does a singularity, an infinitesimal point of infinite density, lurk within? Can humanity ever hope to unearth the secrets concealed within this cosmic enigma? The aura surrounding black holes transcends the realm of academia, permeating popular culture and literature. It serves as a metaphor for the unfathomable, challenging us to confront our fears, explore the unknown, and seek answers to questions that have haunted our collective imagination for centuries. Our narrative begins with a massive star, one that has lived a life of blazing brilliance for millions of years. But as time passes, its nuclear fuel begins to run out, and the star's core becomes unstable. The once mighty star begins to tremble under the weight of its own gravity, and a cataclysmic event is set in motion. As the core of the star collapses, it releases an incredible amount of energy in a blinding burst of light and heat. This event is known as a supernova, a celestial explosion so powerful that it briefly outshines an entire galaxy. The shock waves from the explosion ripple outward into space, carrying with them the remnants of the dying star. But what happens next is where the tale takes its ominous turn. In the heart of the dying star's core, a region of unimaginable density remains. It is here that the star's final struggle against gravity plays out. The gravitational forces in this tiny, compacted space become so intense that they begin to warp the very fabric of space and time itself. In this warped region, nothing can escape the relentless pull of gravity, not even light. This is the birth of a black hole. It is a place where the laws of physics as we understand them break down, and the very notion of time and space becomes distorted. As the core continues to collapse, the event horizon forms, a boundary beyond which nothing can return. It is as if a dark shroud has been cast over the star's once shining legacy. Anything that ventures too close to the event horizon is irrevocably drawn in, disappearing from the observable universe. The formation of a black hole is a harrowing process, a cosmic struggle between a dying star and the inexorable pull of gravity. It is a reminder of the awe-inspiring power and mysteries that lurk in the vast expanse of space, where even the brightest stars can meet a chilling and invisible end. In the depths of the universe, black holes stand as monuments to the relentless forces that shape the cosmos, forever shrouded in darkness and secrecy. In the heart of our Milky Way galaxy, a celestial enigma awaits discovery. Sagittarius A*. This name carries a sense of mystery and fascination as we delve into its story. Sagittarius A** is a supermassive black hole, a colossal entity that challenges comprehension. It resides at the center of our galaxy, shrouded amidst a bustling congregation of stars where their paths are dictated by its sinister gravitational pull. This enigmatic black hole is a compact and voracious beast. Its event horizon, a point of no return, is a boundary beyond which nothing, not even light, can escape its grasp. It is a celestial abyss. For years, Sagittarius A** remained a concealed observer, defying our efforts to unveil its secrets. The event horizon. Telescope's audacious quest bore fruit in 2019 when humanity first glimpsed its dark, foreboding silhouette against a backdrop of searing hot gas, an image that ignited our fascination and fear of the unknown. Around this cosmic behemoth, a retinue of stars performs an eerie celestial waltz. These stars, caught in Sagittarius A's gravitational clutches, move at mind-bending speeds, serving as celestial sentinels to the black hole's inscrutable secrets. Sagittarius A is not the typical voracious devourer of matter seen in other supermassive black holes. It remains eerily quiet, with sporadic flares of activity that defy explanation. Primordial black holes are a theoretical class of black holes thought to have formed shortly after the Big Bang. Unlike the supermassive black holes found at the centers of galaxies or the stellar mass black holes born from the remnants of massive stars, primordial black holes are believed to have originated from different conditions entirely. These black holes are thought to have emerged from high-density regions in the early universe due to extreme gravitational collapse. Unlike other types of black holes, primordial black holes can theoretically span a wide range of masses, from tiny micro-black holes with the mass of a mountain to larger ones with masses comparable to that of our moon or even a small planet. Primordial black holes have been proposed as a possible candidate for dark matter, the mysterious and invisible substance that makes up a significant portion of the universe's mass. These black holes, if they exist, could contribute to the overall mass of dark matter. Detecting primordial black holes is extremely challenging because they would not emit light or other forms of electromagnetic radiation. Instead, scientists rely on indirect methods, such as gravitational lensing effects, the bending of light by gravity, and their potential effects on cosmic microwave background radiation to search for their presence. The existence of primordial black holes is still a topic of ongoing research and debate in the field of astrophysics and cosmology. Scientists are continually refining their theoretical models and searching for observational evidence that could confirm or rule out their existence. These black holes remain a tantalizing and mysterious aspect of cosmology, representing a potential bridge between the early universe and the profound mysteries of dark matter and the nature of gravity at extreme scales. The multiverse theory is a speculative idea in cosmology and theoretical physics that suggests the existence of multiple universes, or a multiverse. This concept proposes that our universe is just one of many universes that exist, each potentially with its own laws of physics, constants, and conditions. The multiverse theory is a fascinating and complex topic, and it's important to note that it remains a theory or hypothesis with varying degrees of scientific support. The idea of a multiverse has its roots in the quest to answer some of the most profound questions in physics and cosmology. It arises from the observation that our universe appears to be finely tuned for the existence of life, leading to questions about why the fundamental constants and physical laws are just right for our existence. There are several different multiverse theories, each with its own concepts and implications. The Many Worlds Interpretation, or MWI. This is a highly controversial interpretation of quantum mechanics, suggesting that every possible outcome of a quantum event occurs, leading to a branching or splitting of the universe into multiple parallel realities. In essence, MWI posits that the universe constantly divides into an infinite number of alternate universes, with each universe corresponding to a different outcome of a quantum measurement. The bubble multiverse theory is closely tied to the concept of cosmic inflation, a theory that proposes that the early universe underwent a rapid exponential expansion. During this inflationary period, different regions of space could have expanded at different rates, leading to the creation of separate bubbles or domains. The theory of cosmic inflation was developed to address several cosmological puzzles, such as the horizon problem and the flatness problem. Inflation suggests that the universe expanded exponentially in the moments following the Big Bang. According to the bubble multiverse theory, during cosmic inflation, the universe's energy density was not uniform. This non-uniformity created pockets of space that continued to inflate at different rates. Each pocket can be thought of as a bubble or a separate region within the greater multiverse. In each bubble, the physical constants, laws of physics, and conditions could be different. For example, the strength of fundamental forces, the masses of particles, and the values of physical constants like the speed of light may vary from bubble to bubble. The bubble multiverse theory posits that each bubble remains largely isolated from the others. The vast distances and different physical laws make it impossible for us to observe or interact with other bubbles. The bubble multiverse theory is a response to the question of why the fundamental constants and laws of physics in our universe appear to be finely tuned for the existence of life. It suggests that such fine-tuning may be a consequence of the vast number of bubbles, with each bubble having its own unique properties. The theory ties in with the anthropic principle, which suggests that the universe's physical constants must be compatible with the existence of intelligent life, because of course, we are here to observe them. Like many multiverse theories, the bubble multiverse is challenging to verify or observe directly. It is largely a theoretical construct, and its validity depends on the accuracy of the inflationary cosmological model. The multiverse theory is highly speculative and has garnered its fair share of criticisms. Some critics argue that it lacks empirical evidence and is unverifiable, making it difficult to test or confirm. Others point out that the multiverse theory might be seen as a cop-out, avoiding the need to find a more fundamental explanation for the apparent fine-tuning of our universe. The multiverse theory has profound philosophical and existential implications. It challenges our understanding of the uniqueness and specialness of our universe and raises questions about the nature of reality, consciousness, and our place in the cosmos.